Hi, welcome back to our third lesson, which is on pointers, arrays, and structures. Earlier on, we made mention of pointers and arrays, but in this lesson, we are going to be going deep into the pointers, arrays, and structures. So, in this lesson also, we'll be introduced to, as I said, the pointers, the arrays, we'll be introduced to pointers into arrays as well, and we'll also be introduced to some other references, structures, unions, and enumeration. So pointers. A pointer is a variable that stores the address of another variable. Pointers can be used with any data type. So in our previous lessons, we learned that we have the integer data type, the string data type. So this lesson is telling us that pointer can be used in a string or integer or any other data type, creating a pointer. A pointer can be declared in the same way as any other variable, but with an asterisk symbol. So over here, we come to our code blocks, then we declare a pointer, or we create a pointer. So the structure of a pointer is your data name asterisk, the name you are using for your pointer creation. Then we come, there's a structure. That's a structure. Then we come to assigning address to pointers. The address of a pointer, which is the ampersand operation or the ampersand symbol, is what we use in the addressing of a pointer. So over here we see some small workings on it, which I'm showing you how you give the address to the pointer. Very simple. It is very, very simple. When we pay attention, we can do it. So when you assign the address to the pointer, it determines the address of the variable in C++, and that is all with the assigning address to the pointer. Then we come on to our next one. So that is a terminal or the control terminal showing us wake. So the referencing a pointer, is the process of accessing the value present at the memory address pointed by the pointer. So with the differentiation, as you know, a pointer holds the memory address of another variable, and the differentiation lets you, the programmer, use or modify the actual value at that address. So we are in our working space trying out some codes, and the asterisk PTR is used to access the value at the address stored in PTR. So we come to modify a pointer address. A pointer can be modified to point to another address if it's of the same type. As I said in our previous lesson, you cannot mix string data type with integer data type on a single line, trying to separate them, like fuse them forcefully to become one. No. So to do that, you have to make sure they all have the same data type, so that you can be able to avoid any error. So we are still on our code trying to modify our pointer. Sometimes when you are trying to code, you see that you make a whole lot of mistakes. It's fine, because we learn from our mistakes, and sometimes you are coding, since we are beginners, we are not very fast with coding, so it consumes a whole lot of time. And as time goes on, the more practice you put into your coding, you get to find out that you start using very shorter time when it comes to your coding. So we move on to our next one. Still on lesson 3 on the pointers, arrays, and structure. We are done with our modifying. Now you come to the data size of pointers. Equal data size for all pointers based on operating systems and CPU architecture. 8 bytes for a 64-bit system and 4 bytes for a 32-bit system. So with all the pointers, since you know that when the code is written, it has to be sent to the memory for processing and all that. If you use a system which has 64, which is a 64-bit system, your coding or your pointer takes up to 8 bytes. So on a 64-bit system, 8 bytes typically refers to the size of a standard data unit that a system can process in one operation. So we have 1 byte, which is equal to 8 bits. So therefore, 8 bits is equivalent to 64. 8 bytes is equal to 64 bits. So it's just like this is a proportion something. Yeah. So a 64-bit processor can handle 64 bits of data at once, which equals to 8 bytes. This affects how data types like ints or long or doubled are stored and accessed, because long takes 8 bytes, double takes 8 bytes, and pointer also takes 8 bytes. Yeah, so you want to wonder why it matters? It matters because when it comes to the memory alignment, the 64-bit systems often align data on the 8 bytes boundaries for performance reasons. And same goes for the 32-bit. Special type of pointers. We have the wild pointers and the null pointers. We have the void. Next is reference. So a reference doesn't hold separate memory address like a pointer. Creating references. The ampersand is used to create a reference. So properties of reference. You access a reference with exactly the same syntax as the same name of an object. A reference always refers to the object to which it was initialized. They come to arrays. And arrays contain multiple objects of identical types stored sequentially in memory. Individual objects in an array are called array elements. Now we come to index of arrays. Index specifies the position of elements in an array. It starts from 0. So with this down there, the place you have the elements in an array, we have 4. We can see 4 values, but when you are counting them, the first value is counted as 0. Initializing of arrays. Initializing arrays refer to defining the element it contains. Example, ints, where we have ints in the array of 3, we can see there are 3 values over there. Accessing array elements. Accessing array elements refers to viewing individual array items, and we have multi-dimensional arrays, and it comes in 2 forms, which you have the 2D arrays and the 3D array. So with the 2D arrays, it has a column and a row. But with the 3D array, it has a column, it has a row, and it has depth. So in the above over there, we can see we have 4 rows, 4 columns, and 3 depths. Struct. A struct, which is a structure, is a sequence of elements of arbitrary types. It is used to create user-defined data types. So this is an example of a struct. Yeah. So we have the struct address, then you input the user data type of what you want there, creating a struct variable. After creating a struct variable must be created. So that's a syntax. Creating a struct variable with definition. So we go into our code blocks to create a struct variable. Struct is like a container that holds the related variables, which are called the members under one name. So on the previous slide, we saw the example where we had the struct address and we had the listed members there. So all these members are held together under one name called the struct. Then your name that you want, you prefer, maybe struct address, then you add it. So with this said, and me trying to code some basic struct declarations, as I try, you can also try with your software. Either you try with a C++, because I use code blocks. I'm using code blocks. Yeah, you can try with other. You can also try with other ones. You can choose maybe VS Code. You can also use your code blocks as well. Any that you prefer. So whilst you are doing this, gradually we can see that we can be building a program. Because imagine you start small, maybe you are building a program, and today you start with this, the following day you can start with struct. As time goes on, you see that you are building the thing. Accessing struct. A struct member can be accessed using dot operator. So this is a syntax. You have the variable name dot the member name. So if you have maybe your struct, a dot member name, let's say the member name, we use maybe school name or university name. So under the struct, you find that location will be there because you want to know about the struct. You find location, you find the address, there's a PO box address or something. So that is more about the accessing struct. Now we go to our next, which is creating a union. A union, just like other user-defined data type, has to be defined before we can use it. Yeah, as I was saying, if you don't define or declare your data type or something, your data type, you can't access it or you can't run it, because you will receive an error which will appear down your code blocks. Accessing a union member. A union member can be accessed using the assignment operator, which you know as the equal to sign. All members share the same memory, unlike struct. So importance of struct. These are the importance of struct. It allocates memory for each member variable sequentially. The size of a struct is the sum of the sizes, and these are the importance of union. It allocates memory only for the largest member variable. All members share the same memory location. So unlike struct, where each is given its own memory allocation, union doesn't do that. Enumeration. Enumeration is a user-defined data type that lets the user assign names to integer constants, and it helps to improve code readability and also group related values. We have the plain enums. The plain enums can be unnamed, and the unnamed plain enums are used when a set of integer constants are needed rather than a type to use for variable. Thank you for joining me on this lesson. Hope to meet you all for more lessons and engage you all for more lessons. Don't forget to subscribe and hit the thumbs button to like and share. Goodbye.